Hello, this is video number 7 on my single variable calculus 2. In this video, we're going to talk about arc length of parametric curve. So imagine if you have a parametric curve given by x equals f of t, y equals g of t, and t ranges from a to b. We want to find the length of this curve. So this is something similar to what we did in the previous video. So we take this curve and we divide it into smaller pieces, and then we add up these segments. That gives us an approximation, and then we let the number of pieces to go to infinity, and that gives us an integral. So we take this interval from a to b, we divide this into subintervals t0, t1, t2, all the way to tn, and then in each of these intervals we take the segment that connects f of ti, g of ti, and f of ti minus 1, g of ti minus 1. So what is the segment that connects these? The segment is obtained using the distance formula, which is f of ti minus f of ti minus 1 squared plus g of ti minus g of ti minus 1, all of that squared. So this is the distance formula. Let me remind you of what we had in mean value theorem. So mean value theorem told us that f of b minus f of a over b minus a is equal to f prime of c for some c, which tells us f of b minus f of a is equal to, if we cross multiply, f prime of c times b minus a. So that means we can take this square root of f of ti minus f of ti minus f of ti minus 1 and write it down as f prime of some ci times delta ti squared plus g prime of some di times delta ti all squared. So let's just see what we obtain from here. So again, we take the segments connecting f of ti minus 1, g of ti minus 1, and f of ti, g of ti. We write down the distance formula. Then we use mean value theorem, and this is what we get. Now we can let ci and di to be the same because they're approximately the same. So when delta ti is a small, this is ti minus 1, this is ti, this is going to approach 0. Ci and di are going to be in this interval, so they're approximately the same. So that means the total length of the arc from A to B is going to be the sum of square root of approximately f prime of ci squared plus g prime of ci squared delta ti. I goes from 1 to n. As we let delta ti to go to 0, we get this integral from a to b of this function, which is the square root of f prime squared plus g prime squared. Now we'll do a couple of examples on this. We have 3 examples, and I'm going to walk you through the solution. So the first one is find the length of the parametric curve given by this. So let's write down the solution. So the arc length is going to be the integral. The limits are from 0 to 1, square root of derivative of x, which is 2t squared, plus derivative of t cubed, which is 3t squared. Derivative of 2 is 0, so we square that, dt. This is integral from 0 to 1, square root of, so this is 4 t to the 4th plus 9 t to the, or rather t squared, and this one is t to the 4th dt, which is equal to integral from 0 to 1. We're going to factor t squared. T squared comes out of the square root because t is positive, because remember the limits of t are 0 to 1, so that means t is positive. We can take it out. We get 4 plus 9 t squared dt. And then we see that the derivative of 4 plus 9 squared is out there, so we can do a u substitution. U equals 4 plus 9t squared. Du becomes 18t dt. So that means t dt is equal to du over 18. When t is 0, u is 4. When t is 1, u is 13. So we can write this down as integral from 4 to 13 square root of u du over 18. So this is going to be 1 over 18. We can integrate that by adding 1 to the exponent, multiplying by 2/3, so we get u to the power of 3/2 from 4 to 13. This is going to simplify. This is going to become 1. This is 9. So that is 1 over 27, 13 to the 3/2 minus 4 to the 3/2. And that is equal to 1 over 27, 13 root 13 minus 4 to the 1/2 is 2. 2 cubed is 8. So this is going to be the arc length of this curve. Next one is another example of arc length. So here is how we're going to solve this. So we're going to take the derivative of x, square that, derivative of y, square that, add them up, take the square root, take the integral. Now I'm going to do the computation first, and then we will uh, write down the integral. So we're going to take the derivative of x with respect to t, square that, derivative of y with respect to t, square that, and then add them up and then take the square root. Derivative of x is 3r cosine squared, but we need to use the chain rule. Derivative of cosine is negative sine, all of that squared, plus 3r sine squared. Again, using the chain rule, we get cosine of t, and then we have to square that. Next is some algebraic manipulation and simplifying this. So we get 9r squared cosine to the 4th sine squared plus 9r squared sine to the 4th cosine squared. So we notice the 9r squared cosine squared and sine squared can be factored. From the first one, we are left with cosine squared t. From the second one, we are left with sine squared t, and that simplifies quite a bit. So this guy is 1. So that gives us 9r squared cosine squared of t sine squared of t. Finally, we have to take the square root of this and integrate. So we get the arc length is equal to integral from 0 to 2 pi 3r, because they told us that r is positive, so we can take it out of the square root, and that gives us absolute value of cosine of t sine t dt. Now, cosine and sine are positive and negative, so we have to take cases. So t goes from 0 to 2 pi. Sine here is positive, and here is also positive. Cosine is positive. Sine is positive here. Cosine is negative. Sine is negative here. Cosine is negative. Sine is negative here. Cosine is positive here. So as you see, the sign of cosine times sine is going to change from positive to negative to positive to negative. So we'll have to break this up into 4 different integrals. So this is 3r parentheses 0 to pi over 2 cosine times sine r is positive. So we can take it out of the absolute value without a negative sign. From pi over 2 to pi, cosine is negative and sine is positive. So I have to put a negative sign. Cosine of t sine of t plus integral from pi to 3 pi over 2 cosine t sine t. And then the last one, when cosine is positive and sine is negative, the product is negative, so we need a negative sign because we have absolute value. So we have 3 pi over 2 to 2 pi, and then we have cosine t sine t dt. I forgot the dt here. Okay, so now we have to evaluate this integral and evaluate it from 0 to pi over 2, pi over 2 pi, etc. So let's evaluate the integral here. Integral of cosine t sine t dt is going to be, if you do u equals sine t, du is going to be cosine t dt. So this is going to be integral of u du, because cosine dt is du, and this gives us u squared over 2 plus c. So this is sine squared t over 2 plus c. So now I can just use that for all four of these integrals. So this is 3r times sine squared t over 2 from 0 to pi over 2 minus sine squared t over 2 from pi over 2 to pi plus sine squared t over 2 from pi to 3 pi over 2 minus sine squared t over 2 from 3 pi over 2 to 2 pi. And then we'll have to plug in those values. So we get 3r times sine of pi over 2 is 1. So we get 1 half. Sine of 0 is 0. Minus sine of pi is 0. And then sine of pi over 2 is 1. So we get minus negative 1 half. The next one is plus 1 half. And then the last one is minus negative 1 half. So this would end up being 6r. Because the sum of 1 half, 1 half, 1 half, 1 half is 2. 2 times 3 is 6, and then we get 6r. So that's the answer to the arc length. Okay, so we'll do one last example on this one, and then we'll talk about an application of this arc length formula. Find the length of this curve when t goes from 0 to pi. So let's start writing it down again. So derivative of x squared plus derivative of y squared. Derivative of x is cosine of t minus cosine of t minus t negative sine of t squared. So derivative of sine is cosine, derivative of t cosine is cosine, and then plus t negative sine. And there's a negative sign in front. Plus derivative of cosine is negative sine. Derivative of t sine is sine plus t cosine. All of that squared. This would be, so these guys cancel. These guys also cancel. This is going to become t squared sine squared t plus t squared cosine squared t. We can factor t squared. We get sine squared plus cosine squared. So that is going to be t squared. That is 1. So that means arc length is integral from 0 to pi, which is what they gave us. The limits of integration were given. Square root of t squared dt. Now t is positive, so we don't have to worry about absolute value. And this is going to be t squared over 2 from 0 to pi. And that gives us pi squared over 2. And that is our final answer. Okay, so next is an application of this arc length formula that we found in evaluation of surface area. So let me explain what this tells us using a diagram. So let's say you have the curve f of t, g of t. So this is x equals f of t, y equals g of t. And we want to rotate this about the x-axis. We get a surface. We want to find the area of this surface. So we want to figure out what's the area of this surface. What we do is we're going to approximate this with slivers of cylinders. Each of these cylinders is going to have some thickness and then some circumference. So first of all, let's see what's the surface area of a cylinder. Surface area of a cylinder, and this is the lateral surface area. So this area, not the top and bottom. If height is h and radius is r, then what you do is you unfold this, you flatten it, and then you get h times 2 pi r. So you get h here and then 2 pi r here. So these are the same, these have the same area. So area is circumference times height. So we do something similar here. We do circumference. Circumference is the radius is y. So y is the radius. So circumference is 2 pi y. And then thickness. Thickness is delta L. So if you consider the curve given by x equals f of t, y equals g of t, and t goes from a to b, and s is the surface obtained by rotating c about the x-axis. We know that the area of a cylinder is base circumference times height, which is 2 pi r times h. The area of a sliver of the surface is going to be 2 pi y, which is the circumference, times delta L. Now, L is the integral of this, so by fundamental theorem of calculus, delta L, which is going to be approximately the integrand times delta t. So that tells us that we can use the integral to find the area. It's integral of 2 pi y times delta L. So this is like dl. This is circumference, 2 pi y. So let's look at a couple of examples on this. Find the surface area of a sphere of radius r. So we can obtain a sphere by rotating a circle, or a semicircle rather, of radius r. If you rotate a full circle, you get twice of a sphere. So we take this one. This is the parameterization for that is x equals r cosine theta, y equals r sine of theta, or t, doesn't really matter. And then theta goes from 0 to pi. This is our angle theta. So now we can find the area using the formula that we had. So we can take dx d theta squared plus dy d theta squared. This is going to be derivative of x with respect to theta is minus r sine of theta plus r cosine of theta squared. Now we can expand this. We get r squared sine squared plus r squared cosine squared. We can factor r squared. We get sine squared theta plus cosine squared theta. This is 1, so this is going to be r squared. So that gives us the surface area is going to be integral from negative r to, or rather from 0 to pi, limits of theta are 0 and pi. We talked about that here because it's a semicircle. And then we have to find the circumference, which is 2 pi the radius. Radius is r, is y, which is r sine of theta. This is the circumference. And then we have to take the square root of r squared, which is r, and then d theta. So some of these are constants, so we can take them out of the integral. We get 2 pi r squared, integral from 0 to pi of sine theta d theta. So this would be 2 pi r squared. Sine becomes negative cosine of theta. And then from 0 to pi, we plug in pi, we get negative 1 times negative 1. So that gives us positive 1. And then cosine of 0 is 1, so we get 2. So we get 4 pi r squared, which matches the formula that we know for the surface area of a sphere. Last example, and then we're going to summarize. The curve y equals x cubed with x between 0 and 1 is rotated about the x-axis. Find the surface area of the surface of revolution. So what we are doing is we're looking at this y equals x cubed, and we are rotating it about the x-axis. So we get a shape like this. So what we need to do is to multiply circumference by arc length. So first we need the parameterization. So parameterization would be x equals t, y equals t cubed, and t ranges from 0 to 1. Any graph of a function can be parameterized using x equals t, y equals f of t. Next, we're gonna write down the surface area. So surface area is going to be integral. They told us that x goes from 0 to 1, therefore t also goes from 0 to 1. 2 pi the radius. The radius is t cubed, square root of dx dt squared plus dy dt squared dt. This is integral from 0 to 1, 2 pi t cubed, square root of 1 plus 9 t to the fourth dt. We can take this as u is 1 plus 9 t to the fourth. So du is going to be 36t cubed dt. So t cubed dt is 1 over 36 du. This is going to be integral from, well, we have to change the limits of integration. When t is 0, u is 1. When t is 1, u is 10. So we get the integral from 1 to 10, 2 pi, and then we have root u. Again, t cubed dt, which is right here, is 1 over 36 times du. We can take all of this out, so this is pi over 18, integral from 1 to 10, root u du, which is pi over 18, 2/3 u to the 3/2 from 1 to 10. And then we have to plug in the values. So that gives us pi over 27. If we simplify this, this is going to be 9. And then we plug in the values, 10 to the 3/2 minus 1 to the 3/2, which is pi over 27, 10 root 10 minus 1. So this is the answer to the problem. Finally, let's summarize what we did. The length of the parametric curve given by x equals f of t, y equals g of t when t ranges between a and b is given by this formula. Integral from a to b, square root of derivative of x squared plus derivative of y squared dt. And the area of the surface obtained by rotating the parametric curve about the x-axis is given by circumference. This is our circumference. And then times dl. And that brings me to the end of this video. So I will see you in the next video.